Hi, the next lesson plan we'll be talking about is all about diving and health. In the subsea industry, divers have a very important role, and there's different commercial divers that they use. Most people are familiar with scuba divers, which means self-contained underwater breathing apparatus. This is what people do when they go on holiday and they go underwater. You take a tank with you underwater. One of the disadvantages about scuba diving is that you can only go till about 60 meters and not much deeper. But when we're doing work underwater, often we need to go a lot deeper. So what they use a lot of saturation divers, is what they're called, which are divers that can go a lot deeper, and they actually stay under pressure while they're underwater. They have these big hyperbaric chambers underwater that the divers can go into, and this enables them to go sometimes up to 600 meters underwater, and they can stay in the chambers while they're working and rest in the chambers, and when it's time to come up, the pressure will be slowly increased or decreased in the chambers for them to come back to the surface. So when we're thinking about diving, we've talked a little bit about pressure already. So when we look as we're sitting here at the surface, all the air in our atmosphere is pushing down on us. And the weight of all this air in the atmosphere pushing down on us, this is called one atmosphere. So it's one atmosphere of pressure pushing down on us. When we go underwater, this pressure quickly increases. If you go down about 10 meters underwater, the pressure will have doubled. So where it's one atmosphere at the surface, when you're at 10 meters, it'll be 2 atmosphere. If you go to 20 meters, it'll be 3 atmospheres. If you go to 30 meters, it'll be 4 atmosphere, etc. And because of this increase in pressure, some things happen to the air in your body. We obviously have air, solids and liquids, and solids and liquids, they cannot be compressed, but air can. And obviously we use air for breathing, and we have sinuses that contain air. When we go underwater, this air gets compressed. So imagine you're a diver, you're going underwater, you're taking a deep breath in, and you're going down from 0 to 10 meters. So as you do this, the pressure doubles. As the pressure doubles, the air in your lungs gets halved because it pushes, it compresses the air, it pushes it down. So your lungs now half the size. If we then go back up to the surface, the pressure halves again, so it goes from 2 atmosphere to 1 atmosphere, and your lungs will be full by the time you reach the surface. So there's no problem here. But what happens with divers, when you go down to 10 meters again, with full lungs, when you get to 10 meters, the size of your lungs will have halved, but then you're actually breathing in extra air to fill up your lungs completely again. Now, if you would go back to the surface, what would happen is if you held your breath, your lungs would actually double the size by the time you came up, which obviously would be quite painful, which is why divers always need to breathe out as they come up. But if there's a panic or you're rising too quickly, this is one of the dangers that divers face, that the air in their bodies can expand and you can have burst eardrums, you can burst your lungs or other sinuses in your body. So this is one of the dangers that divers fear, and one of the problems with diving. So we've talked about pressure and about how air can be compressed and solids and liquids can't. However, there is another thing that does happen to liquids under pressure, and the best way to explain this is with a fizzy juice bottle. When liquids are under pressure, gas can dissolve into liquids, and that's what happens when we make fizzy juice bottle. Under pressure, carbon dioxide gas is dissolved into the water, and it stays there in the solution until the pressure is released. So when we release the pressure, the gas can no longer be contained within the liquid, and we see bubbles forming, which is the gas coming out of the solution. Now, why am I showing this? The same thing happens to divers when they go underwater. So when you dive underwater, your blood, which is obviously a liquid, gets under pressure and can take in more gas. So as you dive down, nitrogen gas from your tissue starts to dissolve into your blood. There's no problem when you stay under pressure, but if you would, like with my fishy juice bottle, if you would quickly rise to the surface and the pressure would be released, just like opening the cap, you could get bubbles forming in your blood. Obviously, bubbles, air bubbles in your blood is not good. It could cause problems everywhere. And this is known as a decompression illness in divers or DBENS. So this is a very dangerous disease divers can get. And the only way to prevent this from happening is by making sure that the pressure is released very slowly, so that the nitrogen gas that's been dissolved in your blood has time to come out slowly. So that's why divers always have to come up very slowly, and sometimes if they've been very deep have to make decompression stops, or why these saturation divers, they're actually in hyperbaric chambers where they can slowly reduce the pressure so that the gas has enough time to go out of the blood and into the surrounding tissues. So that's some of the background behind the Diving and Health lesson plan. We'll move on now then to do some of the activities that are in the lesson plan.